Welcome to Python Flow Control, Decision Making with If, elif, else. In this video, we'll dive deep into how Python programs make intelligent decisions, guiding you through the fundamental concepts of conditional statements and comparison operators. We'll start by understanding what control flow is and why it's the brain of any dynamic program. Imagine you're writing a recipe. If you have butter, use it, otherwise, use oil. That's a decision. In programming, these decisions allow our code to adapt, respond to user input, and execute different actions based on varying circumstances. We'll explore the simple if statement, then graduate to the if-else construct, and finally master the versatile if-elif-else chain, which allows for multiple potential outcomes. Along the way, we'll demystify comparison operators like equal to or greater than, and logical operators like and, or, and not, showing you how to combine conditions for complex decision-making. By the end, you'll have a solid grasp of how to build sophisticated logic into your Python applications. Let's get started. Alright, let's kick things off by understanding the very core of control flow. Think of a program not as a static set of instructions, but as a dynamic entity that can react to its environment. Just like you make decisions every day, if it's raining, I'll take an umbrella, programs need to make choices. This process of determining which code block to execute based on specific conditions is known as control flow. Without it, our programs would simply run from top to bottom, executing every line regardless of context. This would be incredibly limiting. Control flow statements are the fundamental building blocks that allow your Python code to be flexible, intelligent, and interactive. They allow your program to branch out, skip sections, or repeat actions, transforming it from a rigid script into a responsive, decision-making machine. These decisions are powered by conditional statements, specifically if, elif, and else in Python, which we'll explore in detail today. Our first stop on this journey is the simplest, yet incredibly powerful, conditional statement, the if statement. At its heart, an if statement allows a block of code to be executed only if a specified condition evaluates to true. Think of it as a single gatekeeper. If the condition passes, the gate opens and the code inside proceeds. Otherwise, the gate remains shut, and that specific block of code is entirely skipped. For instance, in our accompanying code, we have an example checking the temperature. We set a temperature variable to 28 degrees Celsius. The if statement then checks, if temperature 25. If this condition, temperature 25, is indeed true, which 28 greater than 25 is, then the indented line, print f, its temperature, degree C. It's a hot day. Will be executed. If, however, the temperature was 20 degrees, the condition would be false, and that print statement would be completely ignored, the program simply moving on to the next line outside the if block. This fundamental concept allows us to make small, yet significant, choices within our programs. Now, what if you want your program to do one thing if a condition is true, and something entirely different if it's false? That's where the if-else statement comes in. This construct provides two distinct execution paths, ensuring that one block of code, and only one, will always be executed. It's like a fork in the road. If the condition is met, you take the left path, otherwise, you automatically take the right path. There's no third option, and you're guaranteed to follow one route. Our example in the provided code brilliantly illustrates this with user age. We prompt the user to enter their age. The program then checks if user_aged equals 18. If this condition is true, meaning the user is 18 or older, the code inside the if block, printing, you are an adult, is executed. However, if the user_aged equals 18 condition is false, the code automatically jumps to the else block, executing its statement, you are a minor. This guarantees a response for every valid age entered, providing a clear binary decision. But what if your program needs to evaluate more than just two possibilities? What if there are multiple conditions that could be true, each leading to a different outcome? Enter the if-elif-else statement. This powerful structure allows you to check a sequence of conditions. The program evaluates the first if condition. If it's true, its corresponding block executes, and the rest of the elif and else chain is skipped entirely. If the if condition is false, Python moves on to the first elif, short for else if, condition. It checks that. If true, its block executes, and again, the rest of the chain is skipped. This continues down the line for all elif statements. If none of the if or elif conditions are true, the optional else block at the end will be executed as a fallback. Think of a grading system, like the one in our code example. You input a score. If score equals 90, it's an A. If not, elif score equals 80, it's a B. If not, elif score equals 70, it's a C, and so on. Only the first true conditions block gets executed, making this perfect for cascading decisions. So, how do these if, elif, and else statements know whether a condition is true or false? This brings us to the crucial concept of Boolean logic and comparison operators. Every condition you write, like temperature 25 or user_aged equals 18, ultimately evaluates to one of two fundamental values, true or false. These are special built-in values in Python, known as Booleans. They are the bedrock of all decision-making in programming. To get these true or false values, we use what are called comparison operators. As their name suggests, these operators compare two values and return a Boolean result based on that comparison. They are the interrogators of your program, asking questions like, are these two values the same? Is this value larger than that? Or, is this value not equal to that? Understanding how these operators work is key to crafting precise and effective conditions for your control flow statements. Let's delve into the specifics of these comparison tools. Let's unpack the comparison operators, as demonstrated in the fourth example of our accompanying code. These are the tools that allow us to formulate the questions our if statements answer. First, we have equals equals, which checks for equality. Crucially, don't confuse it with a single equals, which is used for assignment. Number 1 equals equals number 2 asks, is number 1 exactly equal to number 2? Then there's equals, which checks for inequality. Number 1 equals number 2 means, is number 1 not equal to number 2? For numerical comparisons, we have, for strictly less than or greater than. So, number 1 and number 2 asks, is number 1 strictly smaller than number 2? Complementing these are equals and equals for, less than or equal to, and greater than or equal to, respectively. Number 1 equals number 2 evaluates to true if number 1 is either smaller than or exactly equal to number 2. These operators are the backbone of numerical decision-making, allowing your program to accurately compare values and react accordingly, whether it's checking scores, ages, or any quantitative data. Beyond simple comparisons, sometimes you need to evaluate multiple conditions simultaneously. This is where logical operators come into play, allowing you to combine Boolean expressions to form more complex conditions. The first one we'll look at is AND. The AND operator requires both conditions it connects to be true for the entire expression to be true. If even one of the conditions is false, the entire AND expression becomes false. Think of it like needing two keys to open a locked door. You need key A and key B. If you only have key A, the door stays shut. Our code provides a great example, if is_sunny and is_warm. In this scenario, is_sunny might be true, but is_warm might be false. Because one part of the AND condition is false, the entire expression, true and false, evaluates to false, and the message, it's a hot day, will not print. This operator is essential when you need multiple criteria to be met for an action to occur. Next up in our logical operator toolkit is OR. Unlike AND, the OR operator is much more permissive. For an OR expression to evaluate to true, only at least one of the conditions it connects needs to be true. If both conditions are true, the expression is true. If one is true and the other is false, it's still true. It only evaluates to false if both conditions are false. Consider the analogy: you can enter a building if you have a student ID or an employee badge. If you have either, or even both, you're good to go. You're only denied entry if you have neither. In our code, we demonstrate this with if is_sunny or is_warm. Even if is_sunny is true and is_warm is false, the expression, true or false, evaluates to true, leading to the execution of the print statement, good for outdoor activities. The OR operator is incredibly useful when you want your program to proceed if any one of several conditions is met. Our third logical operator is NOT. The NOT operator is unique because it's a unary operator, meaning it operates on a single Boolean expression. Its function is straightforward: it simply inverts the truth value of the condition it precedes. If a condition is true, NOT makes it false. If a condition is false, NOT makes it true. It's like flipping a switch: and on state